Well, today's lesson, we're going to be talking about pressure, which is a very important component when we talk about gases. Now, you're looking here at a mathematical definition of pressure. If you notice, it's defined as the force per unit area on a surface. In other words, pressure can be found by getting the force and dividing it by an area. Okay? So this is a mathematical definition of pressure. Now, we also talked about a conceptual definition. When we were talking about gases, if you recall, we mentioned, let's say you had a container and you had a bunch of little gas molecules inside the container. As they are randomly moving, two things, if you recall, are happening. They're either A, colliding against each other, or more importantly, these particles start to collide against the wall of the container, okay? Whether it's a beaker, a balloon, whatever the container is. The more collisions between these particles and the wall of the container, the more pressure that it exerts. So we can look at pressure from a mathematical point of view, which is force divided by area, or conceptually, pressure has to do with the number of collisions between the particles and between the particles and the wall of the container. Now, how do we measure pressure? Well, to measure atmospheric pressure, you use a barometer. Just like a thermometer is used to measure temperature, a barometer can be used basically to measure the pressure of the atmosphere, whatever the outside pressure is. Now, this device was introduced way back in 1643 by Evangelista Torricelli. Now, if you wanted to measure the pressure inside a closed container, a barometer would be no good. You would need another device called a manometer, and this allows you to measure the pressure in a closed container. For instance, if you are scuba diving and you have a scuba tank, there's a pressure gauge, and that's a form of a manometer because what that does, it allows you to measure the pressure inside the tank, which is going to be much higher than the outside pressure. There's also a little device that looks like a silver pen that people can use to measure the pressure of their tires in a car. That is also a type of manometer, and that, again, it's measuring the pressure inside a closed container. In this instance, the tire is the container, and the pressure in there would be higher. So these are two devices that are used to measure pressure. Now, as far as units, there are multiple units of pressure, and what this lesson is about is to show you some of the different units and so that we can convert from one to another. One commonly used unit in chemistry is millimeters of mercury. You'll notice the abbreviation is mm for millimeter. Hg is the symbol for mercury. And at sea level, the average atmospheric pressure, okay, for gases at sea level, it's going to be 760 millimeters of mercury. And then, in honor of Torricelli, who invented the barometer, if you abbreviate his name also has a unit attached to it. It's called the torr. And the torr and a millimeter of mercury are equivalent. So 1 torr is equal to 1 millimeter of mercury. If I have 760 millimeters of mercury, that means there are 760 torrs. So those two units are equal to each other. Probably what you're going to see the most is that we tend to use a lot the atmosphere in chemistry. The atmosphere is abbreviated as ATM. And an atmosphere of pressure, an ATM, is defined as being equal to the average sea level pressure at 0 degrees Celsius. In other words, if you recall from a few minutes ago, we know that at sea level, the pressure is 760 millimeters of mercury, which is also equal to 760 torrs. Well, that value is the equivalent of 1 ATM, 1 atmosphere. So you already have here our first conversion. Notice that an atmosphere is equal to 760 millimeters of mercury, which is also equal to 760 torrs. Now, we've been talking about units, but the official SI unit for pressure is actually the Pascal, also in honor of another scientist that studied different pressures. And the unit is abbreviated as capital P, lowercase a. That's the abbreviation for a Pascal. And it is defined as the pressure exerted by 1 Newton, a force of 1 Newton, acting on an area of 1 meter squared. So if you look earlier at our formula that pressure is equal to force over area, I don't know if you remember this from physical science, but the unit of force is the Newton, and the SI unit of area is a meter squared. So instead of calling it a Newton meter squared, it was decided to call a Newton meter squared the equivalent of a Pascal. So when you think of a Pascal, that actually is a Newton over a meter squared. And this unit is actually the official SI unit for pressure. Now, here's one final slide I have here. A kilopascal would be equal to 1,000 pascals. Okay? And here's the conversion that's important. There's a conversion that lets us convert from atmospheres to pascals. And 1 atmosphere is equal to 101,325 pascals. In kilopascals, if you divide that number, the pascals, by 1,000, and you convert it to kilopascals, the conversion factor would be equal to 101.325 kilopascals. So notice it's the same numbers, but notice the conversion from pascals to kilopascals, you're dividing by 1,000, so it's 101.325. Now there's even more units. I'm going to mention 2 more. I know meteorologists, when they talk about the weather, they talk about pressure in terms of bars or millibars. I'm mentioning that one there because it's used by meteorologists. We're not going to need to know that one, but we are going to have to know one that's very popular called a PSI. A PSI is an abbreviation for pounds per square inch. And there's also a conversion that allows us to convert from an ATM, an atmosphere, into PSI. And if you look here, an atmosphere is equal to 14.70 PSI. So that's another conversion factor to add to our list. This is from your book. And if you look here, we have the ones you're going to need to know is obviously you got to know this one right over here. Let me just highlight it this way. You're going to have to know from pascals to ATMs. Okay, 1 ATM is equal to 101,325 pascals. Okay, you're going to need to know also that, and I'll put this on the side. So you got 1 ATM is equal to 101,325 pascals, and 1 ATM is also equal to 101 point. Okay, very important there, 325 kilopascals. Then you got that an ATM is equal to 760 millimeters of mercury. An ATM is also equal to 760 torrs, and the reason for that is because a torr and a millimeter of mercury are the same. And the final one, you're not going to need to know inches of mercury nor bars or millibars. The last one that you need to know is 1 ATM is equal to 14.7 PSI. Now, PSI stands for pounds per square inch, but that you'll notice it's written like this. The abbreviation is pounds is LB. Okay, so LB like this. Then per square inch, okay, per means you're dividing, and per square inch or inches squared, this is another way of writing PSI. Pounds on the numerator per square inch, which would be inches square on the denominator. Okay? Now, let's use these conversions to do 2 problems. And before we do that, one final thing I wanted to mention. Earlier this year, we learned about a concept called STP. STP is an acronym that stands for standard temperature and pressure. And this is going to be definitely needed in this chapter. At STP, you must remember that the value in atmospheres is 1 atm, which is the value at sea level. You just learned that an atm is also equal to 760 torrs, 760 millimeters of mercury, 101.325 pascals, 101.325 kilopascals, and 14.7 psi, or pounds per square inch. Okay? So at STP, the pressure will always be 1 atm at sea level, and the temperature will always be 0 Celsius. But since we are talking about gases, we won't be using 0 Celsius. We'll be using 273 Kelvin. Okay? So these are the two conditions when something is at STP. You must memorize these two values so that if something is at STP, you know what values you need to plug in. Now, what we're going to do is two quick examples to make sure we know how to convert. Let's say that we have a road bicycle tire and it was inflated to 125 pounds per square inch. Okay? And if you notice, your tires, whether bicycles, car tires, if you ever read the pressures of these tires, it's measured in PSI. Same thing with this, if you go scuba diving and if you measure the pressure inside a scuba tank, it's measured in PSI. So this is a very popular unit. So the question is, let's convert PSI into millimeters of mercury. Now, based on the units that I gave you, we can't do this in one step. So let's do a roadmap. We're going to have to first go from PSI into atmospheres. And then we're going to have to go from atmospheres into millimeters of mercury. So if you do dimensional analysis, here is what we're going to get. First, you start with the given. The first thing we'll do is we'll convert this to ATMs. So in 1 ATM, there are 14.7 psi. This will let us cancel here. Okay, so we're going to divide by 14.7. And then the second step, so this is step one. Now step two, we want to get rid of the word ATM. In an ATM, there are 760 millimeters of mercury. And you go ahead and you do that there and you set it up that way. Okay? And then when you multiply, well, if you multiply the top, 125 by 760, I'll go ahead and do that on my calculator. And then you divide that by 14.7, okay, you get a very large number. You get 6462.6, and it keeps going, okay? This is going to be millimeters of mercury, but we're going to use significant digits. Notice the original question has 3 significant digits, so we're going to round this to show just 3. There's 2 ways you can do this. You can either do 6460, which is perfectly fine, millimeters of mercury, or you can put it in scientific notation, and it would be 6.46 times 10 to the 3 millimeters of mercury. Okay, and that's how you would do this problem. All right, let's do one more. So let's say that we have, and this is one that you might do often. Let's say you have 32.6 kilopascals, and you want to convert that to ATMs. Now this one's going to be a lot easier than the previous problem because we have a conversion factor that lets us go directly from kPa to ATMs. Okay, so let's put the given first, and then the conversion factor is that in 1 ATM, and you want to put kPa at the bottom to cancel, there's 101.325 kilopascals. So when you set this up, your kilopascals are going to end up canceling out. Okay, now mathematically, this is a one-step problem here. All you're going to do is get 32.6, and you're going to divide it by 101.325. The original question has 3 significant digits, so when I round my final answer, I'm going to round it to 3. Here's my first digit, here's my second, and I got 0.3217. I'm going to go ahead and round this to a 2, and this will be my answer in 3 significant digits. Remember, leading zeros never count. And I just converted 32.6 kilopascals into ATMs. Okay? So it is very important that you know how to use the conversion factors, set them up appropriately, and remember at the end, round to significant digits and always go by the original question. Okay?